This is our next notes in geometry. We're going to skip lesson 5.4 on indirect proofs just to stay away from those proofs for a little bit longer. And next we're going to look at triangle inequalities. And again, with these, I think we looked at them last, 5.3. An inequality is anything that kind of compares relationships between something is greater than, something is less than, and so on, and use those little carrots that point each way. So here we're going to use inequalities to help us figure out the possible side lengths of a triangle. So we have this theorem, and it's called the Triangle Inequality theorem. And this one says that the sum of the length of any two sides of the triangle must be greater than the length of the third side. So like for instance, if we have side AB and we add BC to it, it is always going to be greater than AC. Same thing, AC, BC, AC and BC is greater than AB. And we can just keep going on with the different possibilities. But if we add two sides together, they're always going to be greater than the third side. Okay? So then we can use that to help us prove whether a triangle can be formed with three possible sides. So if we know three sides, we can then plug it into this kind of relationship and see if it's possible to actually have that triangle formed. So here's an example. It says, is it possible to form a triangle with the given side lengths of 8 inches, 15 inches, and 17 inches. So all we do is we add any two sides together and make sure it's always greater than the others. So here we do 8 and 15, it's greater than 17. You see that we add them together, 23 is greater than 17, perfect. Look at another possibility. Instead of 8 and 15, we use 8 and 17. 8 plus 17 is greater than 15. Add them together, 25 is greater than 15. Perfect. Third side, 15 plus 17 is greater than 8. We get 32 is greater than 8. All three work it. This tells us that these sides will form a possible triangle. That's one example. So what about when it doesn't work? Let's check it out. So here we have 6 and 8 and 14. You might see right away an obvious problem. I just did it right away. 6 plus 8 is greater than 14. 14 is not greater than 14. It's not true. So these three sides cannot form a triangle. That's kind of how you do it, kind of basic. So we can also use, not just figure out whether three sides are going to form a triangle or not, we can actually get the range of a triangle length as well, possible length for that third side as well. So let's see how we do that. So an example. If the two side lengths of a triangle are 3 feet and 7 feet, what is the least possible length for side 3? So we're going to say, what's the shortest side for that third side? What's the shortest length it can be to form a triangle? So first thing, there's two basic steps. You draw the diagram. It kind of helps put it in your mind and say, what is this triangle? Could this triangle look like? So we draw a 3 and a 7. And I just, the angles you do, in the end, they don't really matter because we're just going for the shortest possible length. That doesn't mean that this side is going to be that length. It just means it gives us an idea of a diagram in our head of what this is going to look like. Okay, so I did that. I got 3 and 7, and x is the unknown side. And this helps me form my possible inequalities to see what I'm going to end up with. So then if I do that, I set up the inequalities with what I have. So here I have these two sides, 3 plus 7 is greater than x. And then the other one I have is 3 plus x is greater than 7. And then I have x plus 7, the other side is greater than 3. And then I solve these like inequalities, and then I end up with 10 is greater than x. And what I'm going to do is make that into x is less than 10. So we know the maximum size is just under 10 that this side can be. Then we do this one, 3 plus x is greater than 7. We end up with x is greater than 4. Okay, and then that gives us that one. We got these two. Then we look at this last one, x plus 7 is greater than 3. So x is greater than negative 4. When you look at that, it can't be a negative length. It just can't be that. So we know that's not possible. And a lot of times you're going to end up with that. So that's good to remember. So then we take these ones, so we know that x is less than 10 and x is greater than 4. We can then take that and put that into an inequality, a compound inequality, and we say 4 is less than x and x is less than 10. So it's a range. The length of this side, if we have 3 and 7, is anywhere between 4 and 10. That's the length, the range. So the maximum size we can have for x is 10, is really actually a little less than 10, and the largest size, smallest the least size we can have, the least length, is a little bit more than 4. So what it's going to do, it's going to give us possibilities like, it's going to give us 4 maybe, and 6 and 8. So when we have those possibilities, the least size it could be 4, because it has to be greater than 4. So we might go with 6 and choose that choice. Okay? So that's that. So let's look at a couple examples here. So this one says, this is from Check Your Understanding, by the way. So this one says, can you form a triangle with the following sides? 5, 7, and 10. So again, we're just going to plug it into that inequality. 5 plus 7 is greater than 10, that's true. 7 plus 10 is greater than 5, that's true. 5 plus 10 is greater than 7, that's true. So all three possibilities, they can work. That means these three sides can definitely form a triangle. Another example, 3 plus 7 and 8. Or 3, 7, and 8, not 3 plus. So then we have 3 plus 4, we'll just do the first one, greater than 8. 3 plus 4 is not greater than 8, that's not true. So these three sides cannot form a triangle. So that's that one. So we look at this last one. This is the range that we're going to figure out. So it says if the measure for two sides of a triangle are 5 yards and 9 yards, what is the least possible measure for side 3? So we have 5 and we have 9. What's our other side? What's the smallest it can be for this to be a viable triangle? And it gives us possibilities. It's going to do this in your homework, give you possibilities. And then you want to pick the smallest length. So here we have 4, 5 yards, 6 yards, and 14 yards. So which one can it be? First thing again, we diagram it. So we have 5, a 9, and an x. Then we do our possibilities. I've already written them here. So we have 5 plus 9 is greater than x. Then we have 9 plus x is greater than 5. And then 5 plus x is greater than 9. We then solve these inequalities. And for this one, we get 14 is greater than x. So really, that's x is less than 14. Put that over here. And then we have, this one becomes x is greater than negative 4. And that's like, it's not going to be a negative answer, right? And really, if we look at these answers, they're both positive, and they're both greater than negative 4. So really, we don't even need this one, right? It's really extra. Okay, and then the last one, we get x is greater than 4. Okay, so we have these two answers. This one and this one gives us the range. We then put it into that compound inequality, and we get 4 is less than x, and x is less than 14. So then the range we have is between 4 and 14. We then go back to our answers. 4 yards is the first one. Well, it says x is greater than 4. Cannot be this one. And 5 does fit, right? 6 fits as well. 14 does not fit, right? So really we're left with 5 and 6. And if you remember the question, what is the least possible measure? It must be 5. So B would be the answer for this one, 5 yards. That's how you do these triangle inequalities. Hope that makes sense to you. Add these to your notebook, and I'll see you in class tomorrow.